2, port 3. This is for oscillator. This is for memory. This is for memory. So you can remember the function, the pin function, according to this figure. This figure is complex. There's some special about the port 3. Port 3 has two functions. You can use as a parallel port, or every pin has his personal function. Port pin 0 and 1 is for serial transmit. Point pin 2 and 3 is for alternate interrupter 0 and interrupter 1. Port pin 4 and 5 is for timer 0 and time 1. Port pin 6 and 7 is for write and read. External digital memory write and read. The 8 pin can work together as port 3, or can work personal. Individual work. The 8041 has 128 bytes of on-chip RAM. If you
于老师，这麻烦你把那个遥控器借我一下，还是不行。
我
是不是通用？
你试试我看，你试一下，我比较。
是啊，我看看啊，我看能不能通用哈。
Okay. If you want to control a microcontroller, you need to know how to arrange the memory. So you must understand the memory. So there are 128 bytes of on-chip RAM means memory. You can use 128 bytes on-chip RAM and some special function register. Special function register is not used freely. Some you must and remember the special function. This figure tell you the distribution of the memory. Internal data memory. Lower 128 byte 00278 and up 128 byte 82FF. There's two parts. Up and lower. Up 128 bytes is a special function register. We can operate this part according direct addressing. Just use the address. Just use the address to read and write. And 00 to 7F. 00 to 7F. We can use the direct and indirect addressing. The lower 128 bytes of RAM, we can divide it into 3 parts. We can divide the 3 parts. First part, 00 to 1F is for register, just for register. If you know something about the microcontroller, you know R0, R1, R2, R3 is used for user. You can, when you make your program, you can use the register. From 20H to 2FH is for bit addressable area, which means you can read the bit and write the bit, not the byte. OK。
可以。还没给他。
The HH to 7F is user run area, which means you can use it freely. Freely. This figure tells the distribution. 0 to 1F is for 4 bank of 8 register. 20H to 2FH is for bit addressable space. This space can read and write bit. 30 to 7FH is user RAM. You can think of this as a picture. Your RAM is draw on the picture. Firstly, we introduce the register area. From 00H to 1FH. This area is grouped to 4 banks of 8 register, which means there are 4 groups R0 to 7. Four groups R0 to 7. You can select which bank you can use according to the RS1 and RS0 in PSW. Program status words. Selecting for which one. 00 is for bank 0. 01 is for bank 1. 10 is for bank 2, bank 2. 11 is for bank 3, bank 0, 1, bank 0, 2, bank 3, 4 banks, 4 banks. Every bank has 8 register, R0 to R7, R0 to R7. So you can select your bank and use the H register. When the microcontroller 8041 is reset, the default is to use bank 0. When you power on your microcontroller, bank 0 is selected. This allows more efficacious use of code space, since register instructions are shorter than instructions that use direct addressing, which means if you use the register, your program will run faster. Something special. Research initialized the stack point to location 07H, but we not use it common. We will change the location to 30H, which is special. Second part is bit addressable area, which means this area you can access according to byte or bit. The byte address in this area are 20H through 250H, 16 bytes, 6 bytes. The byte addresses in this area are 00 to 7F. This is a byte address. This is byte address. This is bit address. You can imagine the memory like a picture. You can imagine the memory like a picture. So just like this figure, and write and read your memory. That and read your memory. Bit address from 00H, 01, 02, 03 until 7FH. Byte addresses are 20H to 2FH, 20H, 21, 22 until 2FH. This bit can be addressable in two ways. Bit address, for example, 20H. Byte address, for example, 25H.0. We can see from the picture. Bit address 20H. Byte address 25H.0. This is 0.0, 0.1, 2, 3, 4, 5, 6, 7. point. You can add a point, means bit address. 25H.0 equal to 28H. The third part is user RAM area. User RAM space 80 bytes. The address in this area are 30H to 7FH. Commonly, stacks always are arranged in this area. If the stack point has been initialized to this area, enough bytes should be left aside to prevent SP data destruction, which means you have enough space for the stack. This part we need to remember the three parts of the memory. Register area, bit addressable area, and user RAM area. Yeah, the three parts you must remember. It's for lower 128 bytes of RAM, internal RAM. Next, I introduce the ARP 128 bytes ARP. For 51 serials, the ARP 128 bytes is only used as SFR, special function registers, and can only be accessed by direct addressing. Address space from 80H to FH address. For example, we use the code move HH 0AAH, which means put AAH to port 0. This is correct because it uses the direct addressing. Just use the address. This one is not correct because we use R0. Indirect addressing is wrong. Direct only you use direct addressing. Special function register 22 are special function registers. 22. One is not addressable. This is program counter. PC is not addressable. It means user cannot change the PC. 21 SFRs can be accessed. This figure tells the address and the symbol of SFRs. You didn't remember the address, just remember the symbol. The symbol. Mostly we just remember the symbol. If you want to know the address, you just check your book. Just check your book. So you just remember the symbol is okay. It's okay. ACC, B, PSW, SP, DPTR, DPT, point 10 or 23. Just remember the symbol. You needn't remember the address. If you want to know the address, you can check your book. It's IP. It's 0 to 0.7, and every bit has its own meaning. Point 0, parity flag. Point 2, overflow rank. Point 3 and 4 is for register select. Point 5, flag 0 available to a user for general purpose. Point 6, ordinary carry flag. Point 7, carry flag. Carry flag means just like the overflow. Just like overflow. Overflow flag tell the user the memory is overflow, and the CY is recording the overflow. When the microcontroller is reset, the value of SFRs is like this figure. PC 0, 0, 0, A 0, B 0, PSW 0. Only special is stack point 07H. But we often change the stack point from 0H point to another address. Stack operation. For saving breakpoint and scene in invoking a sub-program and interrupt option, which means if you are running a main program, something happened, you need to interrupt your main program and process the interrupted scenes. So you need to save current state of your main program. Save the states in stack. Still stack in stack. Stack point indicates the address of the top of stack. A part of stack just like the memory, just like a part of memory. You can save your state of your main program main program. The operating instruction use push or pop. Push or pop. It's assemble language. Have you ever learned something about C language? Yeah? C language. I know you know something about C language. Just a little.
Yes.
You learn something. You don't know something about C language. Oh, okay. I know something. If you want to make some big program, you need to use the C language. But if you just want to understand the principle of the microcontroller, you must use the assembly language. Assembly language is the foundation of microcontroller. Okay, use the push and the pop. This is assembly instruction. Push operation means SP plus 1 to SP. Write data to stack memory. Pop operation, read data and minus SP. SP minus 1 put it to SP. Just I tell you before, just like a bottom, you put something into the bottom, the address plus 1. If you get some out, the address minus 1. Reset initialize the stack pointer to location 07H. Often we set the stack error in 30H to 7FH, which means in your initializing program, you need set the SP to the value in 30H to 7FH. Any one of is okay. But you need to leave enough space for the stack operation. Okay, let's introduce the into the program memory. Okay, you are Ted. Okay. Into the program memory. This is 51 serial has 4 key program memory. Program memory is used for program, not for running, not for running. Just store your program. And I need to like your hard disk of your PC of your PC, personal computer, hard disk, store your program, but in the microcontroller we store the program in the program memory. Program memory is read-only memory. It's ROM. Means ROM. Yeah.
No access memory.
Access. No. 41 series has 4 key bytes memory. 41 series has 8 KB program memory. After a reset, CPU begins execution from location 0H from H. 5 interrupt vectors are assigned a fixed location. The interrupt causes the CPU to jump to the related location, where it has a non-condition jump. Instruction pointed to a server's routing. This means if you power on your microcontroller, the CPU begin from location 0H. But 05 interrupt vectors. 5 interrupt vectors is store the jump destination. If your interrupt happens, the program will jump to the location to execute your interrupt program. It's a serial port interrupt 23H to 28H. Timer and count 1 interrupt is address. External interrupt time 0 interrupt. External interrupt 0 act. There are 4 points are bidirectional I/O ports for port 1 to port 0 to 3. Each port consists of internal CPU buses, a data output latch, 2 twice-data input buffer, a multiplexer, a max, data output driver, and control circuit. The fourth figure is the structure of port 0 to 3. Most parts are the same, but a little different is here. You can write the rack. This is a resistor. There's no resistor. It's different. Other part is same.
difference between port 2 and port 3?
Port 2, this port, port 2, this
And
What
port 3.
three?
port 3. Port 2 和 port 3, this is max. This is max. Other part, here is the same. Is the same. Yeah. Just there is a max. Max can use for a drive for advanced control or change the switch from this part to this part. This part. This is here is different, but sometimes we didn't consider the internal part. We just know something is related to the out hardware. I emphasize the resistor because when we use the port, if there is no resistor in the internal part of the port, we often add a resistor in the outer circuit. I emphasize this resistor, which means there is no resistor. When you draw your circuit, you maybe you need to add a resistor in your circuit. Can you? Yeah. Port 1, no internal direction because it flows when configured as an input. A high impedance input. After reset, one writes to all port latches, which means if you reset your microcontroller, all pins are set to 0. All pins are set to 0. This figure shows writes 1 to the output pin of port 1. Write 1 to the latch. Enter the CPU. Write 1 to this register. This 1, this 1. This 0. This this is D register. D register. Some register you will name in the numerical circuit or analog circuit. If D is 1, Q is 1. If D is 0, Q is 0. Not Q is 0. So this is 0, 0, 1, 1, 0. 0. So this is Z1. Right, so 1 to D, not 1 to D. So we get the 0 at the Q bar. And so this is VCC. VCC means 1. This means 1. So the flow goes like this. Okay. And maybe you can read some thing on your book. I'll give it to you the electrical book. So if you don't understand, we can explain for you. Okay?
On the drawing, M1, what is the meaning of that sign?
M1.
Yeah.
M1
that sign. Yeah, that one.
M1 it means this symbol. M1 2B.
Yeah, I mean the meaning of that symbol, the extra.
This cannot pass. Cannot pass. This is 0. Means this circular cannot pass. If this is 0, this circuit can pass the.
If it's 1, it can pass.
Yeah. If we got 1, the flow go like this. This ground. This symbol is ground. And so from VCC to ground is 0. So if this 0 and this 1, here will be 0. Here is 0 means this 9, 0. Okay? We write 1 to here is 1. Here Q bar is 0. This circular cannot pass the electric flow. So here is VCC. Means 1. If we write 0 here, 0. Q bar is 1. Means the electric flow can pass here. Here is 0. Okay? Yeah. this write 0, write 0. That can be pass. This is reading high is input pin of port 1. Reading means move AP1, move AP1, and the signal at the P1 go like this. Come here, like this. Come here. So come here, just like this. Next, I introduce the operation of the pin of port 0 or 2, 3. But they are similar to the point 1, point 1. So you can read the book by yourself, okay? Read the book by yourself. Okay, we have a rest, okay, have a break. If you have something, we can talk, okay? What's a clock circuit? To produce time signals for running microcontroller. Clock circuit on-chip oscillator or use external oscillator. On-chip oscillator or 41 microcontroller have an on-chip oscillator which can be used as the clock source for CPU. To connect a crystal or ceramic resonator between the XTAL1 and XTAL2 pins and capacitors to ground. We can see the next page. This pin and this pin connect next this one next. So we can got the internal oscillator working. C1 and C2 about CDPF. The crystal, its frequency maybe 1.2 million hertz and 12 million hertz. Often we use 6 million hertz, sometimes 12 million hertz. If we need a high speed working, maybe use 40 million hertz. Clock circuit we can see in the figure 2. If we got the on-chip clock circuit working, we can get different signal, clock signal, ALE signal, and machine cycle signal. The internal clock generator produces the sequence of states, that make up the microcontroller clock signal, ALE signal, and machine cycle signal. How to drive the clock with an external alternator? Applying to the system that includes multi-controllers. For example, if you have more than one microcontroller, you need them work together. So you must use the same clock. So you must use the external alternator. To synchronize the clock signals among microcontrollers. So you need to synchronize the clock. The external clock, the connector is simple. Just connect to XTL1. XTL2 not connected. Time units. 4 types of time units. Phase, state, machine cycle, and instruction cycle. 4 types. Pulse and state. Phase, oscillator period. State, clock cycle. This state means clock cycle. Phase means oscillator period. Their relation is S equal to P1 and P2, means two oscillator period equal to one clock cycle. Machine cycle. One machine cycle equal to 12 oscillator cycle. One machine cycle to 6 clock cycle oscillator period, 12 oscillator period. If oscillator period equal to 12 million hertz, so one machine cycle equal to 1 µs. The time equal to 1 divided frequency. So time machine cycle 1 divide frequency and multiply 12. We can get the machine cycle. machine cycle. We need to remember the relation of 6 times or 12 times. Well, 12 times. Instruction cycle. The maximum time unit. The time to execute one instruction, expressed by the number of the machine cycle. Right? According to the different instruction, one instruction cycle may be 1, 2, 3, or 4 machine cycle. Next, introduce the working mode. Working mode. There are 3 types of working mode: reset mode, idle mode, power down mode. When you is the input to a Smith trigger, reset is accomplished by holding the reset pin high for at least 2 machine cycles. By reset cycle, while the alternator is running. We can see the reset button on many devices. When your device is dead, you can hold the reset button. For often it needs for 4 seconds or 10 seconds. After reset, PC equals 0H. After microcontroller executes the program from 0H. When the program goes wrong, reset operation can let the microcontroller get out of the trouble. Which means if your program is dead. Reset operation affects the content of some SFR. Idle model. Set PCON point 0 will let microcontroller go into idle model. The internal clock signal is gated off to the CPU, but not to interrupt timer and serial port functions. The CPU status is preserved entirely. SP, PC, PSWA, and all other registers maintain 0 date. The port pins also hold their original logical status. ALE and PSEN bar being pins hold high. 2 ways to terminate the idle. Any enable interrupt or hardware reset. Which means if you want to get out from the idle model, you need give interrupt signal, or just reset. Both of them will cause PCON point 1 to PCON point 0 to be cleared by hardware. You need to clear PCON by yourself. power down model says P.1 will let microcontroller go into its model. This on-chip oscillator stops with the clock frozen. All functions are stopped, but the on-chip RAM and SFR are held. This state is not from the is different from the power off. If you power off, everything is lost. Yeah, everything is lost. But the power down model, RAM and SFR are hold. The port pins also hold their original logical states by their respective SFRs. ALE and PSEN pins hold no. The only way to terminate this model, hardware reset. In this model, VCC can be reduced to as low as 2 voltage. However, VCC must be restored to its normal operating level before exiting power down model. VCC must not be reduced before this model is invoked. Reset will terminate this model, also free the oscillator. Often we use the idle model and the reset. The power down model we use very nice. So today I introduce you some hardware about the microcontroller. I think you need to read the electrical PDF book. So something more specific on the book. Even you got the book, I think the book is not good for you. Because you know, if we want to find some English book for you, it's very hard. Yeah. So I found that book online, but I think the content is not good. So you can read the book and the electric book together. Yeah. We have a rest. After that, I introduce the instruction system. Okay, have a rest.